All right, today we're going to be talking about Chapter 1, Lesson 7. We're going to be talking about specifically Part A, multiplying and dividing with scientific notation. So if you recall from Lesson 3, we had a couple rules. One was called the product of a power rule, and one was called the quotient of a power rule. So if you recall, if we have two powers with the same base multiplied together, this turns out to be A, and we add the exponents. That's what it turns out to be. When we have the same thing and we're dividing them now, turns out that again it's A, and then we subtract the exponents. That is what happens when we have powers either being multiplied, in this case, or divided, in that case. So, in example 1, it says a dime is 1.35 times 10 to the negative third meters thick. What would the height of a stack of 1 million dimes be in scientific notation? So the first thing we need to do, step 1, is we want to get all numbers in scientific notation. So this 1.35 times 10 to the negative third, that already is. So I have 1.35 times 10 to the negative third. 1 million, however, is not. 1 million is this. If you recall from last lesson, converting from standard form to scientific notation, we take the decimal point and we move it until we get a single-digit number in front of the decimal point. And that happens to be 1. We then multiply it by a power of 10, where the exponent is the number of places. So 1, 2, 3, 4, 5, 6. And this number was greater than 1 to begin with. So we have a positive exponent. Step 2 now is we're going to multiply. And so I have 1.35 times 10 to the negative third multiplied by 1 times 10 to the sixth. Now when we multiply numbers in scientific notation, we can use a property called the commutative property to move parts of it around. Because everything's being multiplied together, multiplication is commutative. So I'm going to move the factors, which happen to be this 1.35 and the 1. Those are factors, if you recall that from last lesson as well. I'm going to move those next to each other. So now I have 1.35 times 1. And then I'm going to move the powers of 10 next to each other. So that's that 10 to the negative third and 10 to the sixth. I'm going to evaluate each section now. So 1.35 times 1 is 1.35. 10 to the negative third times 10 to the sixth. That's going to be using this property here. The bases are the same, so I'm going to add the exponents. Negative 3 plus 6 is 3. And I multiply those two parts together. So this is what 1.35 times 10 to the negative third and 1 times 10 to the sixth multiplied together. Now it does say we have units, so we have to include units. So a million dimes would be 1.35 times 10 to the third meters thick. Now in example 2, we're going to be talking about the quotient of a power rule. So we're going to do the same thing. We want to make sure that both numbers are in scientific notation, and the good thing is they already are. Next step is we're going to divide now. Now, when we're dividing two numbers in scientific notation, the best way to do it is to kind of split this in half. So the factors are on one side, the powers of 10 are on the other. Because when we multiply two fractions together, we multiply the numerators, and that's the new numerator. We multiply the denominators to get the new denominator. So this really becomes 8.32 over 1.3 times 10 to the 7th over 10 to the 5th. So that's really what this turns out to be. Now, as we go through this, we need to make sure that we are doing this correctly. So, this part here is the first thing we're going to do, and we're going to divide those two numbers. So, 8.32 divided by 1.3 is 6.4. We're then going to focus on this part here, dividing the powers of 10. So we're going to focus on this rule here now. And what this rule says is if I'm dividing powers, I'm going to subtract the exponents. So same thing here. I'm going to keep the base, subtract the exponents. So 7 minus 5 is 2. And then multiply them back together again. All right, let's look at one more problem. It says the largest planet in our solar system is Jupiter, with a diameter of about 143,000 kilometers. Diameter means the distance straight across through the center. The smallest planet is Mercury, with a diameter of about 5 times 10 to the 3rd kilometers. About how many times greater is Jupiter than Mercury? So first of all, step 1, get all numbers in scientific notation. So diameter of Jupiter is 143,000 kilometers. Unfortunately, that is not in scientific notation, so I need to get it there. So what I do is I put a decimal point at the very end, and I move it until there is one digit before the decimal point. And that happens to be right here. So this number is 1.43. I multiply it by a base or a power of 10, and the exponent is 1, 2, 3, 4, 5. And it's a positive number because the original number was larger than 1. The other number is already written in scientific notation. That was 5 times 10 to the 3rd. Step 2, it says about how many times greater is Jupiter than Mercury. That means we're going to divide. So 1.43 times 10 to the 5th divided by 5 times 10 to the 3rd. Again, I'm going to be kind of splitting this down the middle. So this becomes 1.43 divided by 5 times 10 to the 5th over 10 to the 3rd. First one here, 1.43 divided by 5 is 0.286. 10 to the 5th divided by 10 to the 3rd. We're doing quotient of powers here, so we're going to subtract the exponent. So I have 10 to the 2nd. Now, in this case, it would make sense to put this in standard form, because when we think about how much bigger things are, we don't say, oh, it's 2.86 times 10 to the first times bigger. We would convert this to standard form. So if you recall from, again, last lesson, to get this into standard form, the exponent is really the driving force. This number tells us how many place values to move the decimal point, and because it's positive, it means we're going to move to the right. So this means 2 places to the right. So 1, 2. So this is really 28.6. So we would say that Jupiter is about 29 times greater than Mercury. The reason why we want to change this from 28.6 to about 29 is because in the problem it says about 143,000 kilometers and about 5 times 10 to the third kilometers. So those are approximations, so we want to make sure that we make an approximation as well. Alright, so this is the end of lesson 7A. This is the first part. Tomorrow we'll be doing the second part, which is addition and subtraction. So if you have any questions, please let me know.